lambda, the three values of lambda here, because lambda cube there, where value of lambda must be at least three values. What are those three values? Now from this equation, if I take it is lambda cube in terms of lambda cube, we have to find out the value of lambda, which can give us ABC minus 3 this A cube, B cube, C cube. These values divided by the value of lambda, but it is in cubic terms. Now let me take what is the value of lambda. Let me solve that equation. This is given to us this equation. D is equal to D is 0. Then we will find out this. But it says that these equations are true, means the value of this will be equal to 0 only when the lambda value of lambda is given by this determinant. D say that these values are A, B, C. This is B, C, C, A, and this is A, B. What the determinant value of this lambda value is? How lambda can be calculated? If I just take these two equations in terms of z that we take, so it is equal to minus cz, then solving the two equations. So in terms of the above determinant here, then lambda can be calculated from there. Okay, so I'll just prove that, because if d1, d2, d3 equal to 0, okay, then we take that we express the two equations at least in terms of the third variable z. Okay, we solve that with the help of determinant. Then I'll solve that, and by solving those two equations in terms of z, x by will be in terms of z. Z we will take, let us take is k. The values will come in terms of lambda only. That lambda and these values of lambda will be same. Let me find out what is the value of lambda here. It's nothing but A, ABC minus A into A cube minus A cube. This is right, A into A cube. This is A square, and I multiply A. Let me write here A into A square. Now it's okay. This is BC minus A square. Minus sign minus B into this minus B into B square. This is B square minus C plus C into this is plus C into AB. This is AB minus C square. From this we just calculate that value of lambda is coming. These three values A, B, C. If I just equate the value of lambda, okay, from all the three values, then it can give us ABC or 3ABC minus this value. Let me just solve it. This is ABC minus AQ minus BQ plus ABC plus ABC again. This is minus CQ. BC here, that is 3ABC minus AQ minus BQ minus CQ. These values of D is coming. If I put here lambda equal to some value 0, only then it can be 0. So then the value of D is coming, only these three values will be left over, because they are free from lambda. ABC, this is 3ABC we have written down here. 3ABC, yeah, 3ABC it was, then minus AQ minus BQ minus CQ. Three values were coming, and other values were including lambda. So if lambda is 0, or we equate that to 0, then this value is coming only. But it says, so that there are three real values of lambda, for which the equations this and this and this are simultaneously true. Okay, for truthfulness of them, let me now solve these two equations and then put the value of x and y in the third equation. It will be satisfied. This value then will come out. What is lambda value of lambda then? For value of lambda we have to calculate that what is the value of lambda. Let me just solve these two equations. If I write A minus lambda into x plus B by is equal to minus CZ. The second equation is bx plus c minus lambda into y equal to minus az. Now I solve these two equations and then we substitute the value of x and y in terms of z in the third equation. It will satisfy them. Then we can say that yes, these values are safe. Let me just solve it. Because in this case d1, d2, d3 are coming zeros. But whenever the 3 comes, d1, d2, d3 comes out to 0. Just to prove that these two equations are proved, so we express the other two equations, any two equations in terms of z, and we solve it with the help of determinant. Let me solve it. D will be then, this D is A minus lambda, this is B here, which is B and C minus lambda. This is the value of D. Okay. X and Y we are calculating, and D1 will be in place of this, we have to write minus C minus A in place of coefficient of X. Here it is coefficient of Y as it is D minus lambda. So D1 is this value. X can be then D1 upon D, D1 upon D, that is the value of X. So D1 upon D that we will calculate. First let me just find out what is this value. D comes out to be A minus lambda into C minus lambda minus B square value. And D is, D1 is minus C, so minus C into C minus lambda. Minus plus here AB. So minus AB and minus 1 in between we keep, it is nothing but AB minus C square plus C lambda. This is D1 value. So D1 is this. Now let's write here D1 and D. D1 is equal to AB minus C square plus C lambda, and D is A minus lambda into C minus lambda minus B square. Okay, and what is D2? Because we have to find out only D2, no D3. So D2 will be, now let me write here D2. So D2 will be D2 here. What is D2 value? For D2, we have to put here in place of coefficient of y, and this is A minus lambda, and will be coefficient of x as it is. Coefficient of y will be replaced by this minus C and minus A. D2 comes out to be minus A into this, and this is minus 1 plus BC minus sin A into A minus lambda. Okay, so this comes out to BC minus A square plus A lambda. This is D2 value. Now let me write what are these three values. Therefore, value of x, and this is D2 here, let me write. D2 is BC minus A square plus A lambda. Okay, now if I substitute the value of x and of y, x equal to here, okay, x here is D1 upon D, and y here is D2 upon D, that is equal to D1 is this AB minus C square plus C lambda divided by D. D is A square AC multiply AC, okay, and minus A lambda minus C lambda and plus lambda square, and D2 is here BC minus A square plus A lambda divided by D. is again AC minus B lambda minus C lambda plus lambda square. These two values are there of x and y. If I substitute these x and y in third equation, this one, okay, in place of x, and if I put z equal to k, it must be satisfied then. So in terms of z, I'm sorry, z I just forgot about, because z was also there. We have to write in terms of z, cz minus az, wherever a is coming, z must be there. In place of z, if I write k, then it will be the value. I'm sorry, I just forgot about z here. Coefficient of z, this is minus cz, not minus a only. Minus az and minus cz are to be moved down there. Then those values must be put here in place of x and y. I'm sorry that I just mistook it. So value of d was okay. Value of d was this value. D is okay. A minus lambda into C minus this. What this value is here, A minus lambda, B, coefficient of y is B and C minus lambda. This value is okay. D is okay, but D1, D2 I have just calculated wrongly. Why? Because this is A minus lambda into C minus lambda minus B square. D is okay, but D1 is not that value. So D1 will be, let me write this minus CZ, first equation, minus CZ and minus AZ. This is the value of, in coefficient of x, we have taken these two values, and the B and C minus lambda. This is the value of D1. I'm sorry, I just wrongly, for Z I just missed. So this is this value, minus CZ into C minus lambda, and this is here minus plus here AB into Z. This is value of D1. Now what is D2? D2 I have to write here this A minus lambda and the B as it is. In place of B and C minus lambda, we have to replace by C minus CZ and minus AZ. But in terms of Z, the value must be there. If I write then ZK, that will be this also. This is value. Let me multiply. So this is minus AZ and this is plus BC into Z minus sign minus B keeps. Sorry, this is plus sign. And this is plus sign. Okay, this is minus sign only. Minus AZ into A minus lambda. This value D2 is, I'm sorry, D2 value, this is D1 and the D2 that we write here. So D1 is, okay, D I just, okay, so D value, D was the same thing because D we were having only these two values, C minus lambda, so D was here, A minus lambda into C minus lambda minus B square. Minus B square. Okay, that we have taken, that is D. Now D2 is here. This is BCZ. BCZ. The D1 is this value. This is not D1. D1 D2 wrongly. D1 is not this value. D1 is this. And D2 is this BCZ minus AZ into A minus lambda. And D1 is this value minus CZ into C minus lambda plus AB into Z. Okay, now if I have to substitute the value of x and y, value of x and y is d1 upon d and d2 upon z. So value of Now putting in third equation, value of z. In place of z, if I take z equal to, let me take k. So the value of y we have to then find out. Okay, so that value, let me satisfy this. So c into x. Now x is given upon this. It will be minus cz. Let me take minus cz into c minus lambda, minus c minus lambda. Okay, and plus ab into z. This is c into, because this value is c into x divided by d. D is this a minus lambda into c minus lambda minus b square, and this then plus a into y, plus a into y. Now y is d2 bcz minus az into a minus lambda divided by d. This is a minus lambda into c minus lambda minus b square. Okay, plus b minus lambda into z. That's b minus lambda into z. Z, okay, let's write here z equal to 0. So if I take LCM is this a minus lambda into b minus lambda will be multiplied by this value a minus lambda. The same value will come out. So now let us solve it, because this is only b minus lambda into z. So in place of z, if I write k, that can be done, because this LCM will be a minus lambda c minus lambda minus b square will be multiplied with this z value. Okay, finally this is c into, let me multiply this by c. It is nothing but minus c square z. Okay, this will be c q naught. Okay, let me multiply this c minus lambda and c into this will be plus abc into z, abc into z. So this LCM we have taken to the zero side. Will be the abc into z. Okay, minus a into a, this means a square into z into a minus lambda. Okay, plus now this whole value multiplied by b minus lambda into z. Into z, we are taking z. No problem. This b minus lambda into z into this whole value. So a minus lambda, c minus lambda into b minus lambda, and into z. This value is a minus lambda, b minus lambda into c minus lambda into z. This value is minus b square into this value minus b square into b minus lambda into z equal to 0. This value is coming out to be 0. In this case, if I take z equal to k, we have taken, if I put in place of z as k, what is the value of lambda then? That value, and from there whatever lambda value comes out to be, that must be satisfied. Okay, so now let me solve it further. Here we have obtained z is always coming. If I put z equal to k, this is nothing but minus cq into z. Okay, then minus plus here c square into z into lambda. Now plus here cq, sorry. Okay, this is c square into lambda into z. Okay, no problem. Then plus abc into z, plus this is also abc into z. Two times and three times will come out here. abc, then minus aq into z plus sine a square into lambda z, a square plus sine into lambda into z. Okay, plus sign. You first have to multiply by a minus lambda into b minus lambda. That means this is ab minus a lambda minus b lambda plus lambda square minus lambda square into c minus lambda, sorry, into z here minus now bq, this is minus bq into z plus b square lambda z. What is you? B square lambda into z, this value, and this must be equal to 0, means d is 0. For that the value of lambda will be in terms of z in this case. So from there also we calculate the value of lambda. This is what, in case of z, if I take common throughout, z coming throughout common here, z throughout common, z will also come here, z is there. Z if I take common throughout, let me take z common throughout, that will be equal to 0 here. Or okay, so the same value as we found out from the determinant, same value is coming here. This is CQ minus CQ minus AQ minus BQ. So this minus BQ is here. This is minus AQ minus BQ minus CQ. This value and BQ. Okay, now from this C ABC, this one ABC is coming. By then minus lambda q will also come. The same value what we obtained from that equation, the value of d was equal to 0, because this is the value of d here. C z into d will be 0, that will be equal to 0. So that means this is the same value we have repeated. This is plus 3abc, it was coming here, 3abc was coming, and then whatever the value, all these values, same value as we obtained from d value, that d we calculate, the d is also coming 0, d is 0, d1 is 0, simultaneously then 2. This is the same value. This is value of d, z into d equal to 0, z into d is equal to 0, or d equal to z is also equal to 0, z equal to 0 here. That means 0 upon d, that is 0. Z is also coming 0, x is coming 0, y is coming 0. All the values are zeros when d is coming the same value. Okay, so hence this ninth question is that we have obtained this value of, now we say the lambda value is the value of lambda. Okay, from those two equations we are taking, they are coming of the same type. This value is coming of lambda. Lambda is obtained. If I multiply this, this is ABC as the same value, AQ minus BQ minus CQ plus 3AB. So this value is coming from this equation. So this value, or this value, it must be equal to z into this 0. This is the value of lambda here. Only then that value which lambda comes out to be, then it will be equal to 0. Lambda must be this guy. The value for lambda, true value of lambda, this is for the that the product of these values of lambda, d is this, for that d is this value, because we have seen here lambda, the value from this, the two equations are satisfied, the two equations satisfying the third equation, then this will have the some values, because here d1 0, d2 0, d3 0. For that we take the two equations expressed in terms of z, those values of x and y in terms of z is substituted in the third equation. That is also giving the same value as we obtained from d here. That means for the value of z, lambda, which is this one, this value is of lambda value. Okay, so the same value is coming here. This is true that lambda is that value. So let us take next question, next proof. So this is proof here. Okay, and if there is any misconception in this case, in this question, I'll just clarify this question. What does it mean? Value of lambda for that, well, in the third equation, from third equation, satisfying the third equation, the value of lambda also d, which we calculated from the first one, the same value is coming from the second one. Okay, in terms of z equal to 0, undoubtedly, but the value of d, which we obtained from the first equation, the same value is coming from the satisfaction of the equation. That means for the value of d of lambda, which is obtained by this, the third value, the same value is coming from here. Okay, so this is how, by satisfaction of the equation, that is also giving the same value. Okay, and b is also obtained from these three equations in terms of lambda, that is also the same value obtained. This is what we have proved here. Okay, now let us take 10th question. Okay, so in case just understood, the point is here that whatever the value of d comes initially, the same value of d is coming when we are taking the two equations in terms of z, I mean value of x and y in terms of z, and putting that value of x and y in terms of z in third equation. The third equation is satisfied with the same value which we obtained from d is obtained from this equation. Hence this value of z, and we have seen that this value 3abc minus aq minus bq minus cq is also coming in that equation, that is the lambda value, the value of lambda. We substitute that value of lambda as this value, then that equation will be 0. And this is what question number 9 is. The lengthy question, take the time. No problem. Now 10th question. Now 10th question to 14, 15th question. What this says, it says, show that, okay, 10th question is also the same. We have to solve them by CRAMER'S rule. The question number 10 is of two variables only. Third is 11th is also. 12th is also of two variables section by of z. 14th is also of two variables. Okay, 15th is also of two variables. So two variables equations are given. They are also solved in the same way as CRAMER'S rule. Now let me solve it. Question number 10 now. It says, again we are solving these equations by the CRAMER'S rule, determinants value. Solving this is first equation, x minus 2y is equal to 4. This is equation number 1. With minus 3x and minus 3x plus 5y plus 5y is equal to minus 7. This second equation. This 10th one, minus 3x plus 5y equal to minus 7. And first is x minus 2y equal to 4. First equation. Now we have to solve this equation, find the value of x and y variable. Solving this equations with the help of determinant means, using the determinant by CRAMER'S rule, we have to solve these equations. First, we find the value of d determinant. The value of d determinant we have to first calculate it, but the value coefficient of x is 1, minus 3, minus 2 and 5. This is direct multiplication. Multiplying the diagonal elements first, 5 into 1 is 5, minus plus 6, but minus sign, keep 3 minus signs negative. It is plus minus 6 here only. This is equal to minus 1. Value of d is minus 1 here. What is d1? Okay, in case of d1, when the variable of x, coefficients of x are replaced by the values of the equations. This is 4 minus 7 in place of 1 and minus 3. This is minus 2, 5. Give us 5 for the 20. And triple minus again, which is minus and 40, equal to 6. 20 minus 40, 7 to the 40 equal to 6. And the d2 is, now we have to replace coefficient of y by 4 and minus 7. Equal to minus 7 into 1 is minus 7. Minus plus here, plus 4 here 12 equal to 5. 12 minus 7 is 5. What are the values? Therefore, the variable x is d1 upon d, Now D1 is 6 upon, this is minus 1 here, it is minus 6, x is minus 6, y equal to D2 upon D2. Now D2 is 5 upon minus 1 equal to minus 5. Value of x and y, therefore x equal to minus 6 and y equal to minus 5. These are the two answers. Value of x and y we have calculated. Okay, in the 9th question we have just put that whatever the solution of d value we calculated whatever it comes out in terms of lambda. The same value in terms of lambda comes out to be when we are putting the value of the two variables in terms of the third variable z, and that value of x and y in terms of z is put into the equation number 3rd. Then from solving that equation we see that if I take z common throughout, the same value of d is coming there. Okay, so that is the value of lambda. If I substitute in place of lambda, the value 3abc minus c minus aq minus bq minus cq, which is coming from the determinant value. Okay, so d value is coming from the same, the value of d which is obtained from this, the same value is coming from there, lambda's value. That is what we have to prove in question number 9, not 10th is. Now let me take 11th question. Now question number 11, what does it say? Let me check it. Question number 11. Now it says, get 2x minus y, 2x minus y is equal to what? 2x minus y equal to what? 7x minus 2y equal to minus 7. With these two equations are there. 2x minus y equal to 1, 7x minus 2y equal to minus 7. Okay, second equation. This is the first equation, this is second equation. Okay, solving these two equations again. This is 11th question 11. Only two variables, equations in two variables we are taking here. Solving this with the help of determinants. Solving this also. So d is, just we calculate d coefficient of x are 2 and 7, minus 1 and minus 2. Answer is 2 to the 4, minus 4. Minus in between we keep, so it is minus sign, it will be plus sign 7. It is 3 only. Now d1 is